Now, technically, it's 2x squared over 2, but those 2's are going to cancel, of course. All right, so we got another differential equation here. This one's a little bit easier, but it does ask us for some things that are a little bit different than what we've done so far. So as always, the very first thing we're always going to do with any of these typically is going to be, of course, looking at a slope field so that we can kind of get an idea of what this thing should look like. Okay, so when we're doing that, we're going to look at this equation up here and realize right off the bat that we cannot have y equals 0, right? Because if y is equal to 0, the whole thing isn't really going to work for us, and so we cannot do that. And you'll notice here there's no points there, so there's nowhere for us to actually put a slope in because there shouldn't be one, right? It's undefined, okay? And so we can even just kind of write this in to remind ourselves, okay? It's not going to be defined at that line. And then from there, what we need to do is just start putting them in. So the other interesting thing is going to be that if x is equal to 0, what's going to happen? Well, if x is equal to 0, then 0 divided by anything is going to be 0. So all of these ones here are simply going to be 0. Okay? And then we can start doing these. So let's take a look at when x is 1, because those are pretty easy because we just know that this is going to be -2 over something. So -2 over, let's start with the positives actually. So -2 over 1, because this is going to be -2 times x of 1 times y of 1. And so that's just -2. So this is going to give us a slope of -2. Okay? If I go up to this next one here, the top isn't going to change, so it's going to be -2 times 1, and this time it's going to be over 2. So that's going to give us a slope of -1. Okay? Then if we go down here, you can probably guess what's going to happen because now y is going to be negative. It's just going to flip. But let's go ahead and show that. So we're going to have -2 times x of 1 divided by a y of -1, which of course is going to become +2. And then down here, -2 times 1 over -2 becomes +1. Okay, so they just kind of flip on us. Now let's take a look at this other side here. So now we've got x is going to be -1. So all of these are going to kind of have the same pattern. Let's start with this one here. It's probably the easiest, -1 and 1. So we're going to have -2 times -1, which means our numerator ultimately is just always going to be 2. And what's going to be changing is what we're dividing by, which in this case is just going to be +1. And so we get that this should have a slope of +2. Okay, then if we move up to this one, this part doesn't change. As I said, we're always going to be 2 on the top, but our y is going to change and it's going to be 2, so we're going to end up with +1. And you can probably guess what happens here when our y switches to be negative. The whole thing's just going to invert, kind of like it did before. And so it's going to switch. So we're going to get -2 times -1 still, but now we're going to divide by -1, which of course gives us -2, sorry, -2. And then -2 times -1 over -2. 3 negatives in there is going to give us -1. And so that would be our slope field for all of our points that are indicated there. Now, after that, usually what they'll do is they'll ask us for a particular solution. In this one, they don't ask that immediately. It kind of looks like they do, but really they aren't. What they're doing here is they're saying that if y equals f of x is a particular solution such that it satisfies the condition, which normally we would then go find it, this one says, well, write an equation of the line tangent to the graph at 1, -1, and use it to approximate f of 1.1. So we don't actually need the particular solution in order to do this, all right? So instead, what we need to do, and the way I usually look at this or talk to my students about it, is needing the point of tangency, which in our case is given to us, of course, it's 1, -1. And the other thing that we look for is the slope of tangency. Okay, and our slope of tangency is literally if we just plug those two things in there. And so in our differential equation, we had -2x over y. And so we plug this 1, -1 into that, and we're going to get -2 times 1 over -1, which is just going to be 2. So our slope is 2. So that allows us to write out our equation then. We're going to get y plus 1 is equal to 2 times x minus 1. That would be our equation of the tangent line. Then what we need to do is approximate f of 1.1. So what we're going to do is plug that point in for our x. Oops, minus 1 here. And of course, this is y plus 1 equals 2 times 0.1. Multiply those together, we get 0.2. Then we need to subtract the 1 from both sides, and we get that it's negative 0.8. So that would be our approximation for 1.1. Is it perfect? No, but it is a good approximation. If we continue, of course, now they do say find what that particular solution is. Whereas you'll see here, they just said let it be it. Here they're saying find that solution. So now we do need to actually find that particular solution. So this is where we take our original differential equation, dy over dx, which was equal to negative 2x over y. And again, we need to separate this, get our y's, dy's together, our x's, dx's together. So we're going to multiply both sides by y, because that'll move that y over. And then, of course, we need to multiply both sides by dx, because that'll get all our x's together. So we're going to get y dy is equal to negative 2x dx. Once we've got that, we can integrate them. These are pretty simple to integrate. We're just going to get y squared over 2 is equal to negative x squared. Now, technically, it's 2x squared over 2, but those 2's are going to cancel, of course. And again, as you've seen me do, I'm not going to bother writing the c on both sides, because ultimately, we can just think of it as like the constant, another constant, and then we put them together to get like our third constant. But at this point, it's all just some unknown constant, and so it doesn't really matter if we combine them like that. The only time it matters is once we actually solve for what it is, we need to use that to be the one that we solve for. We can't like plug it in for one other value of c somewhere. So at this point, our next step is to plug it in at 1, negative 1. Okay, so we do that. We're going to get negative 1 squared over 2 is equal to negative 1 squared. And so that just becomes 1/2 equals negative 1 plus c. And so we need to move that over. Again, this is some very basic algebra. Probably don't even need me to see or show you these steps. So we get c is equal to 3/2. At that point, now we need to rewrite our original equation up here with that c value. So we're going to get y squared over 2 is equal to negative x squared plus 3/2. And now what we're trying to do is, of course, get this so that it's y equals, because it's not really helpful for us to know what y squared over 2 is equal. It is helpful for us to know what y is equal to. So first step is going to be to multiply everything by 2. When we do that, a lot of them are going to cancel, but not quite all of them. So y squared will be equal to negative 2x squared plus 3. Then from there, we need to, of course, square root to get rid of the squared. So y will be equal to, and again, as you've seen me do, I prefer to write the positive number first, so 3 minus 2x squared. That'll be our actual equation, or our particular solution that we are looking for here. So again, guys, hope that's helpful. Always check out for more, and if you need more help than this, you can always check out our company, which is in the description link, and we can set you up with some coaching to work one-on-one, or you can take a look at some of our different review classes that we have offered. See you guys later.